name is Robert Reid, and my presentation for Material Selection 1 is over titanium alloys for aircraft landing gear beams. So the paper that I read to gather this information was Material Selection of Optimized Titanium Alloys for Aircraft Applications, and it basically explores the material selection of landing gear beams for aircraft. So they're trying to find out what the best titanium alloys for use in landing gear beams is. And so on the left in that diagram there, you can see a landing gear beam as part of the landing gear on a 757. So methodology, our function is a landing gear beam, of course, and then our constraints is it has to be a titanium alloy, and then the section shape is also specified. The objectives for this are to maximize the specific strength and also maximize the fatigue strength, and our free variables are the component size and choice of material. Our first material index for this is simply equal to the fatigue strength of the alloy, and the second one is equal to the specific strength, which is also equal to the yield strength divided by the density. And so all 52 titanium alloys in the CES EduPack Level 3 database were considered. So on the right here, you can see the chart used for material selection for the landing gear beam. You want to maximize both the material indices. So the upper right-hand corner is where our search region is. Down below, I provided the key of what type of titanium alloy each material fell into, or could be categorized as. And so you can see the probable best three candidates aside from new alloys. Best three candidates using materials from the database are a beta alloy, a metastable beta alloy, and a near beta alloy. One of them is Timet N23, and another is titanium 38644. Those would be good candidates since they have high yield or high specific strength, which is also yield strength over density, and they also have a high fatigue strength. So as you can probably see, it's a little small there, but there are two data points in red that one of which exceeds the three candidates I just listed out. Those were, or the one that does really well is titanium 55511, but those two were the only two in the paper that had sufficient data to be able to plot on this chart specifically. There were a lot of other alloys the authors explored, but none of them had, almost all of them didn't have fatigue strength data supplied. So they weren't able to get a comprehensive list of the absolute best alloy as far as the new or more recently developed alloys are concerned anyway. So in summary, beta-based titanium alloys are the best materials for aircraft landing gear beams. Those are beta, near beta, and metastable beta alloys. And while there are candidates in the CES EduPack that have a high enough specific strength and fatigue strength to meet the requirements for a landing gear beam for aircraft, it's important to keep in mind that more recently developed titanium alloys have the potential and to exceed even the best characteristics of the ones cataloged in the database. And I thought the authors were very thorough in their compilation of relevant mechanical and physical properties for newer titanium alloys, and they wound up making a chart based off of that, but their ultimate decision on which material to use was based off of an approximation. So I wanted to try to, for complete accuracy, use only what was available in terms of fatigue data.